In this video, I'm going to talk about how to plot voltage and current data that's collected in the lab and how to use that data to find the resistance of a resistor. So here's my voltage and current data that you might collect in the lab. And I'm going to talk about how to create a graph. And I'm going to follow 5 basic steps on how to create a graph, which are very common steps, and we're going to end up calculating a slope of a line in this graph, in this lab. So first thing, we're going to define our axes and title. So what I'm asked here to do is to plot voltage versus current, V versus I, and the order is very important. The first variable is the variable that's plotted along the vertical axis. So this is going to be volts, and I'll always put the unit right next to it in brackets. And the other variable is the independent variable, I, and it's plotted over here. So I'll put I, and that's going to be in amperes. So again, just emphasize the order in which these are stated dictates which variable goes on what axis. Then as a title on a plot, we're going to plot voltage versus current. Always put that on your graph so people know what's being plotted. And this can be as descriptive as necessary. So that's step one. Step two, define the axes. So I pre-counted these tick marks. I have 15 going across and I have 19 going up. And what I want to do is try to use most of the graph. So I have to figure out how to define the scale or how to space it out. So let's see here. I'm going up here to 0.67 for my current. If I went by 0.1s, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, I would only use half of the axes here. So I have room because I have 15. I can go by 2. So I'll make this 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. So that should get me up to close to my maximum value of 0.67, which is right around there. For the voltage, I go up to 4, and I have 16 tick marks. So I figure if I use 4 tick marks for every one number, 4 times 4 is 16, that gets me in the range there. So I'll say this is going to be 1, 1, 2, 3, 4, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 4. So I'm just shy of 20, so I can't go up to the next one, 1, 2, 3. But this is a good start. So that's defining the scale. Next I'm going to plot the points. So I just go in order here, and I'm going to plot each of these points. So it's current voltage, so 0.17. 0.17, this is 0.15, so 0.17 is about there, and 1 is right there, so there's a data point. Plot that guy. Then I got 0.25, which is right there, and 1.5, which is the halfway mark between 1 and 2. 0.33, which is just shy of that, and 2. 0.42 and 2.5 right there, and 0.5 and 3 is right there, and 0.58 and 3.5 is right about there, and 0.6567 and 4 is right there. So this set of data is very nice. In other words, all the data lines up very nicely along a line. And this might be the case in the lab, but sometimes you're going to get data that's not as nice. There might be points that don't follow this trend exactly. So for instance, I'm going to make a couple points up here just to emphasize the fact, and I'll use x's. Let's say we had a data point that was here, and let's say we had a data point that was maybe off here a little bit, and maybe off here a little bit, so they're not directly on a line, and maybe off here, all right, and maybe down over here. But the trend is still an upward trend. So that brings us to step 4, draw a best fit line. So when we're analyzing data in any scientific experiment, we want to try to find a trend. So the trend I see is it's upward, increasing, and it looks pretty linear. It looks like a line. It's not curved. So I'm going to draw what's called a best fit line, a line that goes through most of the data points. And as you saw, the dots were the original data. They were pretty nice. And these X's I threw in were some pieces of data that you might collect. that may not fall exactly on the line, but that's the purpose of the best fit line, to find the best trend you can find for the data. So here I'm going to draw my best fit line, and I'm going to draw it kind of like, maybe like this. And you can fool around with the line to kind of, on your paper, I take a ruler and change the angle of the line. I'm going to stick with this one right there. That's the data that goes through most of the points. It doesn't go through them exactly. It might, like this one, close to here, but it may not there, and it might be off by a little bit there. But in general, that's the trend of the line. So at that point, we're going to find the slope of the line. In this exercise, the slope of the line is actually the resistance of the resistor. So let's see how we do that. To find the slope of the line, I need to pick 2 points on the line, on the line, not actual data points, unless they actually land right on the line. So in other words, I wouldn't pick that point because it's not on the line. Basically, once you've drawn the best fit line, you can actually throw the data points out and just use the line as your guide. But let's see, I'm going to choose, and I'll circle them. I'll choose this point right here, because that's a nice intersection point. And I'll choose, what's another nice point to choose? Oh, this one. I'll choose this one right here. It's pretty close to being right on it, a tick mark. So I'll choose those data points. I'll call this point P1 and point P2. And I'm going to list their coordinates and find the slope. And so this resistance is where I'm at now. It's going to be the rise over the run, which is this slope in math class. The rise is this distance here, and the run is this distance here. This is the change in voltage, delta V, change, and this is the change in current. And unit-wise, that's a volt over an amp. And the shortcut unit for volt over amp, that's an A, not a delta. An amp is an ohm, and it's spelled O-H-M. So I'm going to list my data points, and I'm going to find the slope. So point 1 looks like, so I picked that point there, 0.55, 3.25. So that coordinate pair is 0.55, 5, comma, 3.25. And this is I, and this is V. And point 2, it looks like 0.3 and 1.75. 0.3 and comma, these are commas, 1.75. All right, so the resistance is going to be the change in V with the change in I. And so this difference, or this change, let's say it's 3.25 minus 1 over the change in I, which is 0.55 minus 0.3. So if I do some calculations here, you can do that as well. 1.5 0.25 for a grand total of 6 ohms. Box your answer. So the resistance of this resistor is 6 ohms. That's how we define resistance in physics. And if something follows a straight line, so you may have seen this equation in math class, y equals mx plus b. That's the equation for a straight line. If something follows this, v equals I, which is like my x-axis, v equals ri, we can see that here the slope is actually the resistance, or the resistance is a slope. Normally it's written the other way, it's written like this, v equals ir. But in a nutshell, if some electrical device's graph of voltage versus current is linear, we can find the slope of that line and say that that's a resistance, and then it follows Ohm's law, which is this equation right there. And that's a wrap.